Bismillahirrahmanirrahim, in the name of Allah, the most beneficent and the most merciful. My name is Dr. Afsheen Mansoor and I'm working as Associate Professor in School of Dentistry, Shaheed Zulfikar Ali Bhutto Medical University. I did my MPhil from Rifa University under the supervision of Dr. Faisal Moeen and Dr. Masan Mahmood, where I was awarded a gold medal for my research work. I am doing my PhD from Quaid-e-Azam University under the supervision of Dr. Asif Jamal. It's an honor for me to participate in International Brain and Biomedicines Conference. Today, I'm going to elucidate and shed some light on the topic of current and worldwide interest, which is titled as Synthesis of Jasmine Flower-Based Titanium Oxide Nanoparticles and their role in tooth whitening procedures in clinical dentistry. Let's commence about the nanotechnology. Nanotechnology is derived from a Greek word, nanos, meaning dwarf, because it works at the level of atoms and molecules, ranging between 1 to 100 nanometers in size. Nanotechnology is stronger, lighter, faster, smaller, and more durable. That makes it more desirable in the field of medical and dental applications. Now, what is nanodentistry? The incorporation of nanotechnology in diagnosis, monitoring, control, treatment, and prevention of various dental and oral diseases is known as nanodentistry. Let's talk about the synthesis of nanoparticles. There are various methods utilized for the synthesis of nanoparticles. The commonest ones are physical, chemical, and biological methods. Now, here the question arises, why is biological method considered as the best method for synthesis of nanoparticles? The answer to this question is that biological method is safe, non-toxic, sustainable, eco-friendly, cost-effective, and easily available. That makes it more superior as compared to other methods. Now, let's talk about the impetus of the study. Why is this study paramountly indispensable and cannot be ignored? Now, the answer to this question is, in the current era, the patients are in dire need of cost-effective, desirable, biosafe, biocompatible, as well as durable dental treatment in the terms of enhanced longevity and stability with no hazardous effects in the oral cavity. Therefore, dentists have to search for and provide solutions for effective, efficacious, and productive commercial products in the clinical dentistry. Now, the aim of the current study was to manufacture and construct a novel, cost-effective, biosafe, and biocompatible titanium oxide nanoparticles to be employed in the clinical dental practice. Furthermore, this study incorporated two discrete objectives which were attained individually. To fabricate the titanium oxide nanoparticles by utilizing the jasmine flower extract, to assimilate the characterization of titanium oxide nanoparticles synthesized by the jasmine flower extract. Now, let's talk about the methodology for the synthesis of the titanium oxide nanoparticles by the jasmine flower in the phase 1. First of all, the jasmine flower was dried and then they were crushed in a powder form. Then 80 ml of the jasmine flower extract solution and 20 ml of the titanyl hydroxide were mixed together. This solution was heated at about 60 degrees centigrade for 20 minutes until white milky deposit of nanoparticles were formed. This milky white solution containing deposits of titanium oxide nanoparticles were kept in shaking incubator at about 28 degrees centigrade for the next 24 hours. After 24 hours, these deposits settled at the bottom and were washed with the ethanol and deionized water to remove any biological extract left behind in it. These titanium oxide nanoparticles were completely dried in an oven at 80 degrees centigrade for about next 2 hours, and then calcination was carried out in a furnace at about 450 degrees centigrade for 3 hours to get finely powdered form of titanium oxide nanoparticles. In the next phase, these titanium oxide nanoparticles synthesized by the jasmine flower were characterized for their size, shape, structure, surface, morphology, topography, and smoothness in order to incorporate them in the medical field and dental fields. Now, let's talk about the results. The synthesis in the phase 1 was depicted by the visual color change, because the visual color change of titanium oxide nanoparticles from the cream color to pure white indicated the formation of titanium oxide nanoparticles formation. This is being shown in the figure A, where the jasmine flower extract is in cream color, and in the figure B, the titanium oxide nanoparticles have been formed in the flask. In the figure C and D, you can see the powdered form of those titanium oxide nanoparticles synthesized by the jasmine flower. Now let's talk about the second phase, where the characterization technique was carried out. X-ray diffraction pattern analysis was carried out to ascertain the phase and size of the titanium oxide nanoparticles formed by the jasmine flower extract. Now, here the titanium oxide nanoparticles synthesized by the jasmine flower were in 100% anodase phase, having the particle size of about 30.3 nanometer in size. And this is being indicated by the peak at the 101 degree centigrade, which is shown in this graph. Scanning electron microscopic analysis was carried out to calculate the particle size and its shape. Scanning electron microscope analysis of titanium oxide nanoparticles synthesized by the jasmine flower extract revealed prominently spherical shaped clusters with good dispersion at 5000 magnification. These titanium oxide nanoparticles synthesized by the jasmine flower extract were about 32 nanometer in size. The dynamic light scattering analysis was carried out for the hydrodynamic size, and the hydrodynamic size of these titanium oxide nanoparticles calculated by the DLS was about 36 nanometer. The energy dispersive X-ray spectroscopic analysis was carried out to calculate the elemental composition of these titanium oxide nanoparticles synthesized by the jasmine flower extract. These titanium oxide nanoparticles were having the pure peaks of titanium and oxygen, displaying no impurity in their formation. Atomic force microscopic analysis was carried out to ascertain the surface topography. The surface topography of titanium oxide nanoparticles synthesized by the jasmine flower extract displayed a smooth surface having the minimal surface roughness of about 7.68 nanometer in size. Now let's talk about the conclusion of the study. The current study concluded that the titanium oxide nanoparticles synthesized by an energy efficient route utilizing the jasmine flower extract were inexpensive, biosafe, as well as biocompatible, rendering them more potent to be deployed in the dentistry, because size, shape, surface topography, morphology, and particle shape are the most important factors responsible for their biocompatibility in order to utilize them in medical and dental fields. Thank you very much. These were the references that were being utilized. Thank you very much, and Allah Hafiz.